Not yet. It is now. Alrighty, welcome everybody. These are the lightning talks. I'm guessing you're all here for a bit of entertainment and content, of course, but there will be entertainment. This is the third time we're ever doing lightning talks, and the first two times the lightning talks more or less revolved around the creativity of Brooke Schofield, who was the chair. He has another session to chair. The reason I'm doing it is because during the previous lightning talks, I was the one to go overtime the worst. So I guess I'm doing this out of some form of penance. We have a fine list of speakers. There's 15 of them. Every single one will get 5 minutes. You'll have no question time. If we don't run overtime, we will give you an opportunity to voice your questions after all the 15 speakers have finished. But there is a chance that some of them will be like me. There is a device of death. Counts down 5 minutes, has an eerie beep when it stops, and by that time I will drag you off of the stage. Unless you're bigger than I am. Yes, you know who I'm talking about. That is a point of order. One of the presenters is the previous Vice President of Conferences, who was instrumental in getting these sorts of series up, and he's actually now presenting as well, so that's a big badge of honor, so perhaps I might not be dragging him down off the stage. He's also larger than I am. So can I call to the stage? Can I also, as a housekeeping order, invite all the speakers to come forward as much as they can, because you've got about 20 seconds to get up, and I'm not going to do a very large introduction for you, so if you want to introduce yourself, by all means, spend a couple of seconds on it. We'll be starting off with Zarlik Jumbabek Ulu, if I've pronounced this right. Come up to the stage, please. And as soon as you hit the microphone, your 5 minutes will, take it slow, start.
Okay. Good afternoon, everyone, and thank you very much for organizers to keep us this kind of chance to present here. Where is the remote controller? Could you please give me a remote controller? Controller. But you must stop the time, right?
Controller, yes, I will stop the call. I should have done that. That's the controller, left and right.
Left and right, okay.
Sorry, that was... Starting it again.
Okay, let's start from the beginning. This is a small history of about our network. Current project is connecting four countries for now. For example, Kyrgyzstan, Kazakhstan, Tajikistan, and Turkmenistan. And Uzbekistan is still a candidate country. But we hope they will join us very soon. Here we can see all our partner organizations, countries. And of course, now Karen is supporting and promoting these network applications like telemedicine, seismology, distance education. Of course, distance education is the main topic which I will present today. And also, except grid applications, all these applications are already in use. We can use on the base of current network. Okay, this is the main topic for today, Smart School project. In the Sustainable Development Project strategy project for 2013 and 17, noted that there was numerous problems in educational system in Kyrgyz Republic, limiting development and provision quality education. And there was a lot of backlogs in education, not only from the world's needs, but also its own needs and social own needs. And therefore considered to find ways, possible solutions, and innovative education reform. And first, we took a level of secondary schools, and we should review all the content school educational system, and also we should introduce new substance standards and new technologies, and to make students' life much more easier. And in the program, for the development of Smart School project, it was initiated by the EU project, which called Support to the Educational Sector in Kyrgyz Republic, was started in November 9, and they decided conditions of competition implementation of pilot project, and in December 5, 2012, KRENA, Kyrgyz Educational Research Network, won this competition. And the main goals was Smart School is an educational system which learning institutions that reconstruct systems, teaching, learning, and school management in order to prepare children for the information age. Of course, by using the newer technologies, we must benefit from the new technologies, information technologies, to make education system better. And we already made concept program and also concept documentations, and we made pilot project based on one small school. And the main core components was for the Smart School project was network infrastructure, which is wired and wireless, but we prefer wireless, and also LMS, network learning management system, and digital learning contents and core services like federated access and eduroam, and administration and management system, and also teachers and students. Also, we separated the implementation stage into several stages. First stage was preparing infrastructure, and it is preparation of each school's network and network infrastructure, wired and wireless. Mostly we are using wireless, and we are using LMS like Moodle or NetCommons. And also the main issue was implementing core services like federated access and eduroam. And of course, digital contents are also main parts, and teacher trainings, these are the first stage. We just finished the first stage, and we have the next 3 stages to finalize this project. And of course, the pilot project was presented to EU, and it was very successful, and we are waiting for confirmation to start the second stage. And I think I'm running out of my time, and due to limitation of time frame, I couldn't tell much.
I think you did really well.
Questions?
I think you did really well. Unfortunately, we can't. Well done, well done. Pretty good timekeeping. Next up to the stage, Scott Coranda, who knows how to use his time. Excellent work.
All right, so I'm from LIGO. If we can get this pointer to work.
That's the same trick, right? You want to reset it.
There we go. I'm from LIGO, which is the Laser Interferometer Gravitational Wave Observatory. So our mission is to detect signals from violent astrophysical events like the collision of 2 black holes. We do that by building interferometers. This one's up in Hanford, Washington. This one's down in Livingston, Louisiana. Those arms are 4 kilometers long. The lasers go down to the ends, they bounce off mirrors, and they come back to the vertex station, and there we look for the interference signals so that we can detect those signals. We've got about 1,000 members right now in our collaboration, but it's actually a worldwide collaboration. It's not just the US. We have a huge representation in Europe. You can see Glasgow is up there, and Cardiff and Hanover. This is just a small sampling of the sites. So a couple of years ago, we decided to build out single sign-on. We chose Shibboleth. For each of our users, we provision an identity, an electronic identity. We branded it the Albert.Einstein identity. Our users just love that. It's a federated identity. LIGO.org is our scope. We prepared for a federated future, and we joined in common in the United States. But the community is a lot bigger than just LIGO. This is an interferometer built by the French and the Italians in Cascina, Italy. We're very excited. The Japanese are building an interferometer called Kagra under the mountain. That's a pretty big project. And we want to collaborate with all these people using federated identity. But federated identity, while it's really cool, also brings with some new problems. How do we discover those identities? How do we invite people to collaborate with us? How do we enroll them? When you talk about enrolling, then you get onto onboarding. Onboarding leads to offboarding. We have to create groups of people for authorization. So basically, how do we manage all these federated identities? So LIGO got together, we got a grant from Internet2, or with Internet2 from the National Science Foundation in the US, and we created co-manage, which is collaboration management for collaborative organizations like LIGO, like CAGRA. So here's a screenshot. I'm deploying co-manage right now to manage the LIGO-CAGRA working group. So you can see the CAGRA-LIGO working group. Each instance of co-manage can host this enrollment platform for more than one organization. I'm just getting started with CAGRA and LIGO. It's an extensible platform, so each collaborative organization can have multiple enrollment flows, so we can enroll professors one way and graduate students another way. It's extensible. You can require authorization or not. We can do identity matching. You can require approval. You can have different types of notification scenarios, because sometimes people want to be notified. When someone joins the group, other groups don't care. You can collect different sets of attributes during the enrollment. It's extensible, so you can create your own attributes. Physicists love to do that. Here's just an example of a petition. When someone would be enrolling, and you get to decide how the labels look for each project. Again, it's all extensible. And we just added code for doing provisioning, so we can provision all this information into LDAP. We also integrated with Grouper, so you can do all the group management in co-manage as a front end with Grouper. And then we layer an attribute authority on top of it. And then our attribute authority makes this available to all of our service providers, our wikis, and the other tools that we want our CAGRA collaborators to be able to access. So if you're interested, we'd love to have more collaborators. We need more use cases. We'd really like to hear from other projects out there that might have this type of need. And I could also really use people that can code PHP. And I'm done. Thank you.
Wow, you're putting my past performances to shame. Next speaker, Leif. Take it up here.
Hi.
And thank you for filling a slot.
Thank you. So I'm going to break a record here because I have one slide. So before Scott can have his collaboration tools and stuff, he needs to have a federation. Federation building is sort of a black art, the Schwarze Kunst. It's something that federation operators know how to do by anecdotal evidence, and nobody really encodes any tools to do well. Basically, the only two, that has changed in the last couple of years. There are only two tools around for building large-scale federations. One is the one I'm talking about now, the Python Federation Feeder, and the other is the Shibboleth MA1 metadata aggregator number 1. Now, in the world of federation building, we're in the, some of us like to say that we're in host.txt land. We're pre-1980s internet where you didn't have DNS, you didn't have any way to dynamically look up services on the internet. All we have is manually configured trust links. And we need to figure out what the routing protocols for the Internet of Trust looks like. I'm hoping that experimentation with stuff like the metadata aggregators that are being built leads us to some understanding of that. And if you want to participate in this experimentation, then by all means grab this code base or Ian Young's MA1 code base and get in touch with me, because I'm really looking for good use cases where you have collaborative interfederation efforts that don't necessarily follow the usual country-by-country paradigm that we live by today. Today we usually have a federation per country, and they have various, they follow various architectural models. Some of them are hub-and-spoke federations, some of them are full mesh federations. None of them really talk well to each other. We really need to figure out how to get from that point to a global trust reachability for services. And that will take some experimentation, it will take good use cases, and it will take good interoperable code. That's it, Guido.
Thank you so much. And may I remind everybody, you don't have to fill the 5 minutes. I mean, just a single bright idea presented early is much more valuable to me and I think this sort of community than a completely worked-out idea that comes years too late. So I really love these sorts of lightning talks. Hope you guys do as well. Ooh, we shouldn't be doing that. Next speaker is Steve Wolf. Nah, come on, I'm not that sort of a... Take it away, thank you.
Okay. So, yes, new title, so slightly different. Yeah, as you know, in the United States, very few universities actually connect to our national backbone internet too. Most of them connect through regional and state networks, who then, aggregate the traffic and we connect to them. Big data has been much on everybody's mind, and the collection of state and regional networks, who they call themselves Advanced Regional Networks, ARNs. Nobody else likes that acronym, but that's the one they use. They periodically get together and have a naval contemplation session, and the most recent one was back in April, where they discovered that software-defined networking is something that is maybe something that's going to help them use and cope with big data. So, how does this work? No? Ah, there. So big data has all these attributes of things that you need to worry about if you're going to be working with big data. On the other hand, what the regional networks really know about is networking. And if you take the cross-section of these two, the intersection of these two, you get both opportunities and challenges. And where am I supposed to be pointing this? Okay. There we are. Back. There. So this workshop had 27 participants, a whole bunch of organizations, government organizations, the networks themselves, the 3 major US national networks. We even had a librarian and a high-energy physicist there. So the challenges are, they discovered that big data, to handle big data, you span a number of organizations because the data are here, the investigator is here, and there are all these networks and perhaps light path exchanges in between, and the level of network expertise that you have in each of these organizations varies from organization to organization. Secondly, all virtual organizations seem to be different. They have their own set of methods, their own set of software, their own set of techniques of working with big data, and it's not one size fits all. They're all different. And finally, it's a moving target. Even as people are trying to cope with this, the environment is changing. The opportunities. The regional networks decided they really should be talking more with one another and learn about what researchers really need in moving big data, and they should share their knowledge and expertise in moving big data. They need to take a leadership position, anticipate researcher needs, and learn how to be good partners with one another. What they needed was, they decided, was to cope with the situation that was best summed up, I think, by Miron Livni, who's the grandfather of the Condor project. He said, we're coping with a generation of scientists who are analyzing data they did not collect, using software they did not write, on computers that they do not own. And this is part of the challenge. So no, that was the wrong one. The summary is, first of all, skate to where the puck is. Anticipate the needs of the research community and learn how to cope with them. Recognize that all communities are different. And finally, teamwork is it. That's it. Thank you very much.
Excellent. Unbelievable. It's a really easy job for me. Next speaker is not Sad Mandri, who was on the program, but I believe it's going to be Mara. Yes, you've got an extra minute, so you can sort of... Here you go. So it's pointing like that. That's,
Check, is it a good presentation?
aha, that's how you want me to do
Because
it.
it's not my name on.
Actually, it's a good point. Say, operator, where do you point this thing at? Where'd you point it at?
That's for the presentation.
Yes, where do we point it at? Nothing? Just anywhere. All right. It's a bit slow. And this really shouldn't be going off your time, so... Yeah, sort of, yep.
Stay here, push a button, and I will talk.
Oh, that's nice. Look at how useless I am. See, this is...
Stop.
Oh, great. Would you mind just quickly, because...
Yeah. Oh,
Yeah, it's sort of slowly moving back and forward.
No, but this, there are two different PCs.
Right.
There's only the PC with presentation.
Righto, okay. So this should work, right? Yep.
Yeah.
Okay, excellent. Well, forward it on, and if it isn't moving, just give me a sign, and I'll give you an extra 30 seconds or so.
okay.
Is it good for you?
Okay.
That's the slide pack you need?
Yes, yes.
Perfect. Your microphone's over there.
Okay. Thank you.
And good luck.
First, to clarify what is openness resolver and why it's potentially dangerous. Okay. It's a DNS service which responds to any recursive queries from any host on the internet. And if you have such an open resolvers in your network, then you might become unwitting participants in one of a very disruptive attack. That's the amplification DNS attack. And that attack is done through DNS query. Queries are small, the response tend to be large, and if enormous number of responses are sent to the same target, I mean either infrastructure or service, then the internet performance can suffer on the global scale. Even the New York Times published a story about that, and it's no doubt it's a dangerous thing and should be closed. What does it mean? It means to configure DNS to configure DNS server in such a way that accept recursive query from legitimate host, that's host clients from your own network, from your own address space, and deny it to the rest of the world. And simple as that. Still, we have more than 2 million open resources around the world. Why? The only reason I was able to find, and the most often mentioned reason was user not aware of the danger. But please be cautious, and please try to find another reason, because if you have a persistently open resolvers on your network, in our case, in our neuron, we identified that lack of a security DNS feature available on the Microsoft DNS platform can make the problem that DNS service supports primary zone file for more than at least one domain, and when a DNS service is on a network segment with basic security protection, I mean when it's protected by packet filtering on the router, on uplink to the neuron. So in that case, it will not help to send reminder to your campus staff to close resolvers, even don't help to send a link to a Microsoft technical note, because deeply inside the documents, they will find that only options available is to disable recursion queries for all hosts. So solution will be to add another DNS platform which is capable to selectively deny or accept queries depend on where it's come from, source IP address naturally. And our campus staff are not satisfied and not happy with this solution because they already choose a proprietary solution and now have to maintain another box in their network. So there's not problem with all this virtualization to do that same thing on the near-end side and provide same on the near-end side. But then campuses complain that they have to outsource very old and basic service which they provide successfully. So from their points of view, you know, they choose as the most preferable solution this one with additional firewall, and that means any gear which provides stateful packet filtering. But as any preferable solution in our lives, money is the problem because there are small institutions with very, very low, modest budgets. And all because of this, they choose to wait on Microsoft to add more option on their platform, which only is not solution because they stay with resolvers open. And I will finish with some useful links where there you can check, file check, you open resolvers for single domain, for range of addresses, and for every IS you want. So, thank you.
Very well done, very well done. Slides will be made available after the conference, so links will still stay up, etc. Next speaker, Brian Nisbet, with, I think, we're not actually handing out a prize for this, but most intriguing title? Imprecise network monitoring tools. I saw you upload this thing, and I was like, I have to see this, and obviously I will. Go ahead.
Cool. So, I'm Brian Nisbet. I'm the Network Operations Manager in HEANet. And I'm going to point this that way. That's going to work. Imprecise network management tools. There are a bunch of caveats before I go into this. These are imprecise, really. This is a secondary information source at best. This is kind of the network monitoring equivalent of a guy down the pub told me something. People on the internet, and this is where we're getting our information, are often wrong. Do not trust these people with, you know, your mortgage, your son, your daughter, valuables, etc. Do not go home and turn off all your other tools after hearing this talk. People will laugh at you. So when I say imprecise network management tools, what do I mean? I mean Twitter, primarily. Fantastic source. All the world's information is now flows through Twitter at some point or another. Of course, XKCD got there before me. That's as much time as you get for that. Facebook, also another imprecise network management tool. Nowhere near as good as Twitter because you can't search for it as easily unless you're following the right people. You don't get that information. So, but there's still lots of useful information there, and indeed lots of people put information. Lots of universities put information up there. So what we're talking about is crowdsourcing network monitoring information, generally during something going on. So what are the use cases for this? When we say these tools, where do they actually play? Is $VLE down for everyone or just me? So a remote hosted VLE, someone's complaining to you, they can't reach it. That VLE is claiming that, well, the problem is clearly with your network, not with theirs. Do a quick search for, I don't know, a random one. And find out if other universities in countries next door might be having that problem. By the way, all these use cases are from personal experience. So check, is Blackboard up in the, $VLE up in the US or in the UK or otherwise? Has the campus lost power, just connectivity? We had a campus, we lost connectivity to it. I went onto Twitter, I did a quick search for the name of that university to find out if they'd lost complete power over the campus or just connectivity. Because no one was complaining about the lights being out or the vending machines going down. I knew that it was connectivity they'd lost. Has the local computer services department noticed something they haven't told you about yet? Maybe they've tweeted about it or put it on their Facebook page, but they haven't gotten around to sending the official emails that might land in your knock or otherwise. So, you know, if you follow these accounts, you'll get to see all of this stuff. It's not sneaky. They can see that I'm following, you know, all of my wonderful, wonderful clients, and they are wonderful, wonderful clients, can see that I'm following them, but they're putting that information out there, and I can see it. Configuration hints for these tools. Find the relevant official accounts and follow them. There's lots of them out there, and I suspect more of them out there than you think there are. This is a reactive searching tool. Unless you're very, very good and have coded this all up, and if you have, please God, tell me, you will not be able to really get this stuff as a proactive tool. It's going to be something you're going to be using during an incident. And don't just search locally. Don't just search in Ireland or wherever you happen to live. Really, don't just search in Ireland. It may be completely irrelevant to you. The internet's a very big place. There's lots of information out there, so cast your net as wide as possible. However, of course, with configuration hints, there is then alarm filtering, because alarm filtering is important. Huge amounts of noise. Huge, huge amounts of noise, especially on Twitter. Dear holy God. And I spend a lot of my time on Twitter. And of course, during an incident, that increases a lot. Many students complain all the time about having to study until they suddenly can't study. And then, well, my God, I was going to get that essay in, except for the fact that Moodle went down. It's not my fault. So you'll get a lot of that, but that's also incredibly useful in these situations. And institution acronyms can often be very, very widespread. DCU, Dublin City University, a football team in the States, and a superhero universe. So you get a lot of additional noise in there as well. But during an incident, the relevant stuff for DCU will kick up a lot more on that Twitter search, unless, of course, the football team are playing at the same time. Finally, that's me. Please follow me, talk to me, email me with any thoughts about this. Thank you very much.
Thank you so much. Thank you so much. Next speaker up, Julio Ibarra. My pronunciation is horrible. Julio Ibarra.
Yes, very good.
Close enough. Excellent. Thank you very much.
This one to advance.
Tool. I think it's the other way around.
Oh.
And so therefore, right is front.
Yep.
Off you go.
That works. Thank you. I'm going to give an update on the Open Science Data Cloud. And this is also part of an award called, or from an award through the Partnership for International Research and Education, PIRE. The Open Science Data Cloud is an open source cloud-based system, and it targets for the use of scientists to manage, analyze, integrate, and share large-size scientific databases. It works as a distributed facility, and it depends very heavily on networking, especially 10 gigabit connections, because the idea is to move large data sets between these different cloud resources. On the right-hand side, you see a design of how the system is organized. There is currently a deployment in Chicago with a Hadoop cluster. There's also another one in Miami for storage clouds, and they're interconnected through 10 gigabit links at this time. On the bottom, you see a list of icons. These are the partners involved with this project. It's led by University of Chicago, and participating also is University of Illinois at Chicago, Florida International University, and the Open Cloud Consortium. The architecture of the OSDC involves a number of different user services to provision virtual machines and to provide a number of different functions for a cloud infrastructure. There is a web-based application called the Tukey web system, named after John Tukey. For those of you who may have heard of him, some historical information. He's the mathematician who coined the term the bit for binary digit back in the 1940s. And with this system, you're able to use a web interface to work with these different modules. The contribution to this system, which then led to this lightning talk, is to be able to automate the whole process of installing this cloud system. Currently, It's a very manual, labor-intensive process. As you can see in the very bottom, there's a line in red font, of all the different open source packages that are integrated to form this open science data cloud system. And so there really is no install type system to simplify the process. And that's what this slide here shows you. It's organized into 4 components: the initialization process, then followed by installation, an after install component, and then a check process to ensure that the installation has been done correctly. A lot of this will work remotely. You're able to start with the initialization process, and from there, remotely start to be able to install the other components. So the idea is to go from bare metal to a compute and storage cloud in a more efficient way. Some of the projects that are currently using the Open Science Data Cloud is Project Matsu, which is a collaboration between NASA and the Open Cloud Consortium. And they're using this open source technology for doing cloud-based processing and working with satellite imagery to support Earth sciences. The other application involves biology. It's called BioNimbus. And there was a recent article in the NSF Digest that describes this project. And as you can see here, it involves working with large genomic databases, and it's used by a number of projects that include the mod encode and the encode, and with the genes consortia. So this system is being used in a number of different disciplines to make the data available in a cloud infrastructure that can be then utilized by the users that are participating in the OSDC project. One of the key and very important components of the project is the work that this group is doing with international partners. This slide here shows you a number of different students from U.S. universities that have participated in the OSDC. Okay, and so here is the students, and if you have any questions, here's a list of contacts for further information. Thank you.
Well managed. Thank you very much. Well managed. Next slide, Pag. Excellent, yes. Next speaker is Janusz Ulanowski. Not exactly a name I had expected over at HEA.net.
Yeah.
You're very what? Multicultural.
Yes,
That sounds excellent that way.
Okay, I've been working for HS since 2008 as an educate operator. So one of my objectives was to build a federation management portal to make federation management easy and how would say easier. Okay. So it's used in production since 2012, and it's open source. Also, 2 other federations are testing it, and it has 5 components. Federation management provides metadata, attributes policy, and synchronization tools, which are used for inter-federation. Main features, multi-federation, of course. So provider may not only be used in national federation, but also can establish bilateral agreement. Advanced attributes policy, and next, disclosures. So you can see only IDPs, SP trust, yeah? Benefits, everything is in one place. So the idea was, as you can see in bottom right, there's a single link, and entity can pull this metadata instead of every federation. attribute review policy, and for federation admins, just everything in one place. How we do interfederation? Of course, we are not part of EduGain yet, but we going to be. So how we do it? A home organization who wants to join EduGain don't have to touch configuration. Everything will be in this portal. And next, just improvements. Thank you. Very quick. Thank you.
Caught me there. Fantastic. So are you ready? Because you caught both of us out. Next speaker, Professor Hiraki.
Yep.
Take your time.
No.
Let me see. Yeah, you got it right. I don't think you actually have to point it at anything. You just have to have a bit of patience, I think. There you go.
Go back, no go back.
Indeed.
Okay.
Go back.
Oh, okay.
Is it working?
Okay. My name is Kei Hiraki from University of Tokyo. And this is a call for collaboration on the series of experiments to realize the efficient utilization of 40/100G network. There's a series of the progress in the network technology. So 100 meg, gig-E, and 10G, and now 40G. And in each technology, we have steps of the utilization. And for example, in 10G, at first that is used locally, then globally, and popular use. And I think that our group contribute a lot on the global use and the popular use. And as for the 40G, 100G, the global use is already there, and some researchers start using the local use of the 40G, but there is not yet the popular use because there is no long-distance TCP communication on the 40G because there is many problems. And for example, this is a current stage of the utilization. So many slow systems. Now the backbone is 40G and 100G. Then the step two is a kind of the UDP application that utilizes a backbone, a full backbone 40G, 100G network. Because UDP is not sensible for the packet losses. Then this is our target one. So single server to single server, single TCP stream, but that utilizes a full 40G network. Then this is the final shape, the utilization of the full 40G using some web browser or some of these kind of the popular application. So our target of the series of the experiment this year and next year is to realize the step 3 and step 4 of the utilization and popularization of 40G, 100G network. And in some sense, in other words, this is, the speed graph of the Internet to run speed record. So the 10G is achieved in the 2005 by our group, and our target is now, around 4 times more than the previous record in this year. Oops, what happened here? Okay. But the 40G is much more difficult than the 10G. One is the CPU speed. Still, the top speed of the highest speed CPU, the 100G occupy all the memory bandwidth of the memory. And the next is, PCI speed. So Gen 3 speed is just sufficient to the 40G network and not sufficient to the 100G network. And TCP scalability is also the big problem. Because only single loss of the packet decrease 40G bandwidth a lot. So it's already a big problem in 10G, but it is a very tough problem in 40G network. And also, the current software, especially the Linux software, is not compatible with long-distance 40G network. And still, many other unknown problems. So these are technologies we already use to fully utilize the 10G network. And we achieved 99% of the TCP efficiency using this network. But now we developed a new technology for 4TG. The detail is in the poster number 23, but now we use the machine learning technology to distinguish the packet loss by TCP congestion and packet loss by the optics network. So we can ignore the unnecessary packet losses for these 4TG traffics. So this is call for collaboration. So we have technology of the end system, but we don't have any 40G, 100G long distance because Japan is a small country and Pacific Ocean is so big and there is no such kind of network. So we want to evaluate 40G network anywhere in the world. So the series of the experiment starts the Q4 this year. We want to use the 1 or 2 weeks of this network to make next step achievement. Please, if you are interested in collaborating us on this very fantastic 4TG experiment, please contact us.
Wow, it's unbelievable. Everybody's short in time. Next speaker, Otto Wittner. Ready for it?
Yeah, let's go.
Hope it works.
Okay, my name is Otto Wittner from Uninet, the Norwegian Envern. And I'm going to tell you a little bit about something we've been working on for a couple of years now. Low-budget music collaboration tools and experiments. This is something which is not really new. The Italian GARB guys, they have been doing this for some time, and the Internet 2 have activities in this domain, and several others. But we have also started doing this, so I'll just tell you a little bit about that. Maybe. Okay, try again. Here. So I've tried to picture here the music collaboration tool space, and there are sort of one issue which is significant when you're doing musical collaboration or artistic collaboration, and that is delay. It tends to make things complicated when you are collaborating with where artists are collaborating, especially when they are playing traditional music over the wire. And there have been developed quite a few tools over time, and this is essentially video conferencing, so I've also included video conferencing tools in my diagram here. And I tried to sort of make a few axes or dimensions here, illustrating the quality parameters involved in this tool space. And what we're really looking for is large green dots up in the left, well, up the upper part of the diagram. I've illustrated delay as a large circles are short delay, and low costs are green here. And as you can see, there are quite a few green dots around here, but they are not necessarily very large. So the open source and low-cost tools available today, they tend to struggle with actually coping with getting the delay to a minimum. And LoRa is really the tool developed by GAR and others, which is performing best with respect to delay, as far as my impression is. And I mean, this picture is really dependent also how you configure these systems. It's important to say. So this is kind of a snapshot of how it might look. And we see that the expensive systems, the yellow ones, they are not really too high up. The more traditional vendors of video conferencing systems, they tend to compress things a lot. So musicians and artists, they are sensitive to distortions caused by compression. And there are some commercial tools not doing too much compression in the audio domain, but still in the video domain, but essentially they are very costly. I mean, you're talking hundreds of thousands of euros for equipment. So we are currently been testing some of these tools, and what the application we've tested is conducting a choir online. And in Trondheim, And why do we do this? Well, conductors are busy as other professional musicians, and choirs tend to be really hard to move around because there are a lot of people, like orchestras in general. So we've done some experiments with the church choir in the city where UNET is located. It's 40 singers approximately, and first a few years ago we tested a long distance session from Trondheim all the way to Lisbon, which did work well at all. We had borrowed some professional equipment and it did work, and we used standard video conferencing, which was a disaster. And then later we have tried in the lab, and we've realized, as other actors here have realized before, that you really need to get below 100 milliseconds, one-way delay, and at best should be below 50 actually for the musicians and the artists to be comfortable. So in the winter this year, we've tested the distance from Trondheim to Oslo in Norway, which is around 600 kilometers. And with the ultra-grid tool, we managed only 200 milliseconds return delay, which is a bit too much for a conductor. But they are professional musicians, so they could handle it, but they were not comfortable. So essentially, a key message here is that it turns out that if you investigate these systems, the camera and the display and the end systems in these setups, they are really the obstacles. So, quickly about collaborations in Europe, 10 seconds.
This one slide.
This is only the last slide. So, what's interesting in Europe is that the geographical distances are rather short. We have about 35 milliseconds across whole Europe, so collaboration with online tools should be possible. And we also have high-capacity networks currently in NRENS plus the Giant network. And but there is some. I mean, there are so many low-cost tools available, as I illustrated, but there is some interoperability issues which can be sorted out and probably will. And there'll also be in sort of separate communities, is my impression, worldwide working on this topic. But they seem to be joining forces now, and they've all been invited to this World Opera workshop in Struer in Denmark in August. So if there are anyone here which didn't know about this workshop, make a note of this. Thank you.
Thank you. Well done. Well done. Wow, you guys, everybody's faster than I am. Hi, Jens.
Right.
And thanks again for that last-minute scramble to get your slides up. I wish you well.
Okay, thank you. So I'm speaking about the experience with reusing AI. So the last thing when you've got a project, the last thing you want to do is run your own authentication authorization infrastructure. So you want to try and reuse what's already there. And I'm speaking today on behalf of two projects, one of which is called Contrail, which is building federated access to clouds. So you log into a portal or something, and you can control multiple cloud resources, IS, and pass in underneath it. And your credentials would get delegated and do stuff wherever they need to go. And basically, it's based on a front end which generates it accepts your credential and it generates an X509 certificates underneath it. This was chosen for pragmatic reasons because X509 works really well with everything we need to talk about. But there are lots of other technologies underneath that, and here's a very rough diagram of the. If you start from the top, you log in using your external identity provider. It goes into a simple SAML PHP identity provider, which in turn converts that into a SAML assertion, which is accepted by an OAuth authorization server. If it all looks complicated, it's all done for a certain reason, because we use OAuth for delegations, and we use X509 to actually talk to with a single federation identity to all the services that we need to talk to. So the basic principle is to use what's already there. Use what the user communities are already using. If they're already using Shibboleth, then we use Shibboleth. If they're already using OpenID, then we use OpenID, and so on. So the other project is called EODAT, and it's building an infrastructure for storing data for projects and user communities. And they have, again, a very diverse set of user communities, so supporting them is very challenging. And this is their view that, again, you have the external providers and you authenticate using portals in the boundary of the circle. which then converts your identity to something that's accepted all over the federation. And all the little blobs inside are then the storage resources where your data lives. So my talk today is not really about the projects, but more about the experiences that the projects have had when they came and decided to reuse AAI. The first one should come as no surprise that it's software related, because you're building on components that do things, so you need to take components from other sources that other people have developed, and it has to be sustainable. You have to have the right features. Often the software that has the most features is the least mature, and vice versa. There are some project-related things as well. When you manage a project, you need to manage the dependencies and the people who are working on it and integrating it. Is it easier to develop it yourself, or or should you spend the time to integrate an external product? How long should you spend evaluating things that others have made? So for the software-related stuff, my recommendation is that you basically build a risk register. What are the risks for taking it? You evaluate them by each component and understand the consequences of using those. You build user communities, and you have workshops where you integrate things. For the project collaboration, I suggest you keep it informal initially, and then you can work on more formal arrangements if you need it. You also need to work with user communities. That's essential, and getting them engaged up front is important, but it's not always possible. So see if you can find experts in user communities and get the first couple of communities working, and then the rest will follow, hopefully. They need to see that there's something driving it that'll push them towards using your infrastructure. And then the infrastructure itself, because you're using something that's outside your project. You're using federated AAI. And that brings me to, why are we still doing this? We're still talking about authentication and authorization, and there's still things that are missing. So for my future wish list, sort of for existing AAI infrastructures, I want to support user privacy, to define policies for releasing data, for managing, for tracking what my data is doing out there. I want client-server negotiation, where clients and servers negotiate what sort of attributes they actually need, and maybe a couple of attributes of one flavor is as good as one of another. The revocation problem, Contrail has a notification mechanism. If an attribute changes, it will notify the policy decision point. Something like that is useful for dealing with these things. And make it driven by policy so users can define the policy and don't have to get into the nitty-gritty stuff, and make things smarter to get the attribute negotiation done right. So users will have more control over how their attributes are managed. Thank you very much.
Well done. I suspect some of you people for having practiced this in front of a mirror. Unbelievable. By the way, did Brooke Schofield just tweet that he was hoping that I was doing a worse job than he was last year? Fabulous. Thank you, Brooke. Excellent. Alrighty, next speaker, Eric Ruiter. Eric Ruiter, I can pronounce this really well. It shouldn't be too hard. Yeah. Off you go.
Okay.
Is it all working?
I think so.
The time starts now.
Okay. Thank you. My name is Eric. I work for SurfSara, which is a part of the Surf organization, just like SurfNet. SurfSara provides many services for NRENs, like computing, storage, and cloud services. What we also do is a part of a bit of network innovation, and part of that I want to have this talk about. We developed some plugins for monitoring Ethernet ORM. Well, I'll first give you a 1-minute introduction into Ethernet OEM. Well, it's let's say method standards, tools related to working with Ethernet. Well, currently we are having 2 standards available for connectivity fault management. Basically, they allow you to work with an Ethernet connection as if it was a layer 3 connection, because normally in layer 2 you don't have any pings or trace routes, Well, this enables you to do pings and trace routes to layer 2 connections, which is getting more common since service providers provide Ethernet more and more. Well, you have two standards, the .1AG and the Y7031. Both of them implement the ping and the trace route. They also have a CCM check. That's a continuity check, which allows you to keep sending keep alive for each second of 100 milliseconds. And the Y standard also has some additional messages for delay measurements, jitter, packet loss. And yeah, well, why did we want to, well, what did we do with this? We developed a plugin for the Isinga platform and a graphing template to use with Cacti. These are two commonly used monitoring platforms which are open source, free to download from a lot of places. I'll go into them in the next slide. Why did we do it? Well, we are a small team. We manage a lot of things. One thing that we don't want to manage is an additional monitoring system for Ethernet OEM. So we wanted to look into a way to do this into our existing system. Well, this of course saves us time and resources. And well, we're quite happy with it. Okay, first what we did was a plugin for Isinga. Isinga is a fork of the Nagios monitoring system. It allows you to send periodic polls to switches, servers, anything you like. You can create scripts for monitoring different things. We did one to monitor remote maps. These are management endpoints, and they're actually an Ethernet OEM node. You can see that it shows a list of maps and what their status is. It also tells you what management domain and management association they have. And it reports if it sees any alarms. Especially, it's made for the CCM checks. If it misses alarms, it will send, it will trigger a flag, and you will get an email. And in this way, you have a layer 2 monitoring. And yeah, you can also filter specific maps if one node has multiple maps. What we also did is a template for Cacti. Which can show you delay and jitter variations. It's only tested on a Sienna because it allows the specific DMM option. And well, that brings me also to vendor support. It's not complete for a lot of vendors. There are often errors in MIBs or in firmware, and we found a lot of issues that makes you ask, is this really already mature, and are vendors taking it seriously? And well, this is all. We also have a booth where we give a demonstration, and you can download the plugin, and there's a short tutorial as well where you can try it if you like. Okay, thank you.
Well done. Here's the man I'm proud to welcome on the stage.
Yeah.
Thank you for endorsing our lightning talks.
Yeah, thank you. And hopefully this will work.
Please keep it to 5 minutes because I'm not going to drag you off the stage.
Okay, thank you. Oops, sorry. How did it end? Okay, that's fine. So, hello everyone. My name is Miroslav Milinovic. I work for the University Computing Center, University of Zagreb. And we are actually the federation operator, identity federation operator for Croatian academic and research community, and we also operate Croatian EDUROM. The initial title of this talk was VLAN probe, and our nice chairs actually added or proposed us to make the title a little bit more clever, so it's last mile diagnostics and monitoring problem. And it was actually motivated with the fact that in a more than we want situations, we have users claiming that eduroam is not working and we have no clue why. Okay, this is not really true, but it sounds like that when you follow the Twitter or the other not so perfect monitoring tools. And so the task was actually motivated with that, but the idea is to have a perfect diagnostic tool, the one that would be as close to the user experience as possible. And of course, it won't work only for eduroam, it would work for any wireless LANs that you would have, or SSIDs, or mechanisms of authentication, or whatever means of access, wireless access you provide. So the idea actually is, to monitor the last mile, to make sure your tool is, or appliance actually, is as close as possible to what the users can do. So we decided to build a probe that will monitor wireless LAN or the eduroam service at a certain location. The task is to get all the available SSIDs, to check the signal strength and quality, to see what methods of authentication and crypto methods are used, and after that, do the functional eduroam test. This means authenticate and perform an action. Typically, download the file from a distant web server, something like that. And at the end, the aim is to collect, store, and analyze all the data this probe is collecting and make it available for the local admins, but also for the operator, if there is one of a set of service locations, so she can kind of learn what's going on at a certain location. For instance, IP pool is being exhausted, DNS is down, DHCP server is not working well, or things like that. All of this has nothing to do, for instance, with the eduroam, but still a user's message would be, your eduroam is broken. Well, definitely, it might be. And by the end, our results will be available in the open source. We still don't have a GitHub place, but we'll have it soon. This is the platform we selected, and this is the actual device. We didn't smuggle it here, but it's back home in Zagreb. This is version 0.0. We decided to use the Raspberry Pi hardware, Linux, and the Python 2.7 is the software development platform we are using. What we have right now is the working system that scans for signals and SSIDs, can give you the information about the signal strength, can give you the information about how many access points it sees around. It does functional eduroam testing. We have the test IDP used, so no test accounts needed. We have ours. So it does eduroam authentication, so it provides you with information, did it work or not. Data is being sent to the central monitoring place via syslog. So this, for those who are more involved around the eduroam, they know about the FTX. So here is the idea reinvented again. And you can see a screen that's also one of the possibilities. So due to the hardware that we selected and the platform, it's possible to connect your device to a large screen and present to the admins what's going on with their local network. This is a picture, so you probably, this is a photo, so you can't probably see it quite right, but it shows how many access points are there, channels, SSIDs, cryptos, and all the stuff. So if you are interested in this work, please, here is the contact address, admin@eduroam.hr, and we'll be willing and hoping for some cooperation. I know that this idea is not the only one. There are some others in that arena, but we would really like to see something operational. And that's it. Thank you.
Couldn't have asked for a better job. Next week, there you are. Splendid entry from side screen. Here's the person who always dwarfs me. Take it away, Miriam.
Hello, thanks. Wait, this is not me. Oh, this is me.
It is you, yes. It is.
Hi, yes, I'm Miriam Kühne. I work for the...
Check whether the machine works and...
Yeah, it does.
Off we go. Perfect.
Oh, can we go back? Go back. Yes, I'm Miriam. I work for the RIPE NCC, which probably many of you know. It's in one function, it's also the secretariat of the RIPE community, which is a similar group Terrainer is a bunch of network operators come together and discuss various things, and also part of it is policy developments for things like anything to do with IP addresses, AS numbers, and so forth. And we started a new initiative, a new project. In a way, I wouldn't say we stole it, but we got inspired by the poster project here at the Terrainer conferences the last few years. And we thought it would be good to also get some new students and academics, or mostly students, into the RIPE community. And so we started this project called RACI. And I just want to quickly introduce this to you. Wait, click. Thank you. So what's the benefits? Well, obviously for the students, they get free tickets, like a free ticket to the meeting. The idea is that they provide a talk or like a proposal to the RIPE community. The RIPE program committee reviews them and selects at least one for the plenary session, and possibly also others can be presented during some of the working group sessions at RIPE. The idea really was to focus on local candidates and local students from wherever we are at the RIPE meeting. I'll get to that in a second. Well, obviously, it's nice for the students. They get to see, they get to meet with other people in the community, get to go to the operators meeting, learn from others, expand their professional network. And it's also good for the RIPE community because it brings new ideas, fresh blood, other proposals and to the meetings. So we started to launch this at the recent RIPE meeting in Dublin in May, not too long ago. And we had 5 students there. Only 2 actually were local to Dublin. Others came from various other universities in Europe. But they were all very excited. It was really good to have them there. They were really good. They spoke to tons of people. So I think many of them and also many of the attendees got a lot out of that initiative. So we have good feedback so far. We did this together with HANet in Dublin. Obviously, they helped us identify some of the students. But so it seems to be difficult to reach out to students at local universities. And so we're kind of looking for help. At the next meeting, which will be in Athens later this year, we're obviously working together with GRNet to reach out to local students there. But I just wanted to bring this to your attention here. If you have any ideas or if you know any students in your universities or in your entrance, please by all means let us know and come to us, speak to us during the meeting here at the RIPE NCC booth, or also contact us later by email. We want to improve this over time and provide some project or some place for students at the RIPE communities, and that's it.
That is excellent. That brings us to our last speaker, who I must confess I kind of duped into preparing a set of slides that is a bit too good, because the lightning talks actually said slides and or demos, and so Tim here actually prepared a demo, and now it turns out that there's no keyboard here. So I think the first couple of slides you'll be fine, right? And by the part where we get into the demo, how about I give you 2 extra minutes, because we're kind of early, and if you want to take a plunge, by all means. But if anything fails, it's my fault, all right?
Okay.
Take the opportunity.
I might introduce some extra failures just to pay you back. I won't need the extra minutes because without a demo, we'll have a little to show, but you'll have to use the power of your imagination as I describe it. So this is a late opportunity, but I'll happy to take advantage of it to tell you a little bit about EduConf. We're task 6 of NA4 in the GÉANT project, and our objective is to assist the GÉANT members in using video conferencing. So to do this, I'm the new task leader, by the way. Rui is, I don't know if he's in the audience, but Rui, oh, there he is, hello. Rui was the previous leader for the last few years. A lot of this work's been done under him. We concentrate on 4 areas here. I will show you the directory at the end, which is the bit I was hoping to demonstrate, but of course I can't type in my password without a keyboard, so we're cut short on that. And certification is part of the directory. Addressing, we're working very closely with the nrennum.net community to take another step forwards towards maintaining the addressing area. We're hoping to use nrennum to move the GDS, which is currently, the global dialing scheme currently exists on a hierarchy of gatekeepers maintained by NRENs. We're moving that structure over to DNS, which is what nrennum will give us. And that will be for SIP URI addressing as well. So we're concentrating in the addressing world and trying to assist NRENs with using that. We're doing some monitoring, and this is an appeal here. If you run a national gatekeeper for your NREN or your country, and you'd like to add your gatekeeper to our GDS monitoring system, all we need is 2 GDS E164 numbers from you, and we can monitor your gatekeeper and provide a health map of the GDS, which might help to give people a little bit of confidence that their dialing's going to work. I will move on to the directory and certification. This is the front page of the directory. The objective is to help people to find video conferencing systems and users of video conferencing systems across mainly Europe at the moment, but it may spread further than that eventually, as we're about to sign an agreement with Elsira, which is in the South American region. The current version of the directory is brand spanking new. We launched in March, so we've got very few members at the moment, so we need to grow. You can see there the EduConf membership is represented very well on in the NRENs that have already signed up, from Poland, Croatia, Serbia, UK, Portugal, and a few others as well. You can see there's very few dots on the map, so this is an appeal. If you're interested in using the EduConf directory and you would like to register some of your VC systems, we're going through a process at the moment of greatly simplifying the registration process to make it very easy. One of the great benefits of registration is certification, which means that you can test your video conferencing system. You give us an E164 number or an IP address of your VC system, and we run our certification process, which I would have demonstrated. It basically provides on the screen, you get a little number for you to type into your VC system and dial to check that the GDS, to check that you can make outgoing calls, and we then call you back. Same for IP addresses, and we're hopefully going to introduce SIP, check into that at some point in the project. So certification is a testing process, and at the end of it, you get a nice little sticker and a certificate for you to stick up in your room if you so desire, or stick on your laptop if you're using that. So that's all I can really show you at the moment. The URL will probably help you get a bit more from this. EduConf directory. Please visit, have a look at the VC systems if you want, register one. If you're interested, if you want any more help with this, if you represent an NREN that wants to start using this or wants to add yourselves to the Gatekeeper Monitoring Network, then get in touch. You've got myself, most of you probably know Rui, who's sat somewhere at the back in the dark. Please come and find me. Unfortunately, my other set of slides that I would have tried to upload had contact details, but you're going to have to guess them from the core site online. All right, thank you very much.
Ouch. Thanks for not introducing too many more mistakes. 0, in fact. That brings us to the close of this session. We've got room for a number of questions, but of course there's 15 speakers, and I don't actually know if there's a roving microphone. Is there? Is there? There is. So if anybody has any pressing questions, there is one. Of course there is one. The Dutch. And please make sure that tell us what speaker the question is for. Speakers, on your toes, please. Is this thing on? So it's a suggestion to the last speaker, and it is to hook up EduConf to EduGain. I don't think that microphone's working. Yes, it would. I'm feeling particularly useful here. Yes, it would. Excellent. Further questions? No further questions, I don't think. Would you guys mind joining me in an extra thanks for all of these 15 speakers? I think they've done an absolutely excellent job. And I know